So today's discussion is about real numbers and rational numbers. So what are real numbers? We have learned in primary school about pi, right? Okay. Pi, root of 7, and cube root of 5 are called irrational numbers because they cannot be expressed in the form of a over b, where a and b are integers. And of course, b is not equal to 0 because any number divided by 0 will be indefinite, or in another way of saying is imaginary number. We'll discuss about any imaginary number next. So why root of 7, why pi, why cube root of 5 are called irrational numbers? Because if you turn these numbers into decimals, it will be a never-ending list. Pi is usually 3.14 or 22 over 7. But actually pi, if you Google it, you can try to Google it, it is a never-ending decimals. So it's like 3.14, blah, 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 5, blah, 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 blah. So it'll never end. You can try to put root of 7 into your calculator. It will also never end. Well, if it ends in your calculator, that means because your calculator cannot hold anymore, right? So it decides just to put an end to it, but actually it never ends. So these kind of numbers again are called irrational numbers because they cannot be expressed in the form of AV, A over B. Even the number pi itself, which usually we know as 22 over 7, is not really a 22 over 7. It's just like the rounding. Okay? So now we are talking about the bigger picture, which is real numbers. So real numbers is made up of rational numbers and irrational numbers. So irrational numbers, the one that we talked just now, and rational numbers are just the other number except irrational numbers, like whole number, fraction, even the positive one or a negative one. Yeah, you can see the example here. Let's move on. Now we talk about irrational numbers. Yeah, the number that can be expressed in the form of AB, of course. Something like 2. Yeah, even 2, we can express it as a fraction, which is 2 over 1. Something like that. And if we are to break down rational numbers again, rational numbers is made up of integers and fractions. Okay, and integers is made up of whole numbers and negative integers. Yeah. So whole numbers here is actually just 0 and positive integers. So the one you usually see on the number line, the simple number line like negative 3, negative 2, negative 1, 0, 1, 2, 3, they are called integers, right? We move on to the next page now. Because we were talking about fractions here, which is included in the rational numbers, now we are going to discuss a bit more about the fractions. So, we also learn in primary school that there are 3 kinds of fraction, which is proper fraction, improper fraction, and mixed fraction. There should be ED here, right? MIXED, yeah, okay. So mixed fraction. If you forget about it already, improper fraction is just like a proper fraction, but the numerator is bigger than denominator. The top one is bigger than the bottom one. And the moment you have improper fraction, that is the moment you can turn it into mixed fraction, which is just you divide it, and then you take the result and the remaining and the number that you divide with as the element that form the mixed fraction, which if you forget already, I'm not going to discuss it here. You need to find another video to teach you again how to do mixed fraction. Okay, now let's review again how to add fractions. So we are doing an addition of 2 over 3 and 3 over 4 here. Now the problem here is that denominator is not the same. So we need to find the common denominator of 3 and 4. Okay. If you never know about this, I'm going to tell you that the common denominator will be just the LCM. Again, on the previous chapter, we already learned about LCM, which we can use here to find the common denominator. So for 3 and 4, the LCM is just 12. So it is a sign that we need to change these 4 and 3 into 12, which we times 4 to 3. And the top one also got the 4, yeah? And for 3 over 4, we times both by 3. It is all just so that the denominator can be the same, which is 12. And then it will become 7 over 12. 17 over 12, I mean. And you can change it to mixed fraction, but we are not going to do it here. Next one. Okay. I also provide you with this to review, which is how to turn the mixed fraction into improper fraction. Now, after we have that all that knowledge, we can head directly into the work example. So here, for the question A, the topic here is to do an addition of mixed fraction and another negative mixed fraction. Okay, you should understand by now why we learned about the negative numbers, right, on the previous discussion, because here we're going to use it here. So the way you do it, you change the mixed fraction into the improper fraction first, usually, right? Okay. Also, there's another way here. If you look at the textbook, what they do is they don't change it directly to improper fraction, but instead they minus the whole number first. So they treat the whole number and the fraction separately. So 6 minus 2 first, that's how you get 4 here. And then 1 over 5 minus 3 over 10. Yeah, find the common denominator and then just minus it. Okay, but the thing here, because the first fraction is smaller than the second one, yeah, 2 over 10 is smaller than 3 over 10. So you need to borrow from the 4. So you pull out the 1. Pull out the 1. This is the 1, the 10 over 10. If you add this 10 over 10 again to 3, you'll get 4 back again, right? So you pull out the 1, change it to 10 over 10. So y must be 10 over 10 because the fraction we are talking about here has a denominator of 10, right? So we change it to 10 over 10. So this is to help the 2 over 4. Sorry, 2 over 10. So it become 12 over 10. Yeah, 12 over 10. So 12 minus 3, 9. Okay. You should have learned this in primary school. It is just a review. So I'm not going to discuss about question B again. So it'll be just same with number A. Sorry, the slide is just keep going back. Okay. Now, next one, still about fractions, but not addition, not subtraction. This is about multiplication and division. So in multiplication, please note this, please do remember this, that you don't need to find the common denominator. Yeah, it's just for the addition and subtraction, because in multiplication, you just times the top with the top directly. So 3 times 2, 6, and 3 times 5, 15. And then you simplify the 6 over 15 into 2 over 5. Now, or here you can cancel out the 3 first. Cancel out the 3 first, and then you're just left off with 2/5. This one is the same. You just need to change into improper fraction first, and then lastly the division. Now, see what I color here. So you can see here that for division, you can just turn it into multiplication by turning the fraction upside down. So the fraction that you're turning is not the left one, but it's on the right one. So the right one, you just turn it upside down, and then you're good to go. And this is just another example of another multiplication and division of fractions, which involve negative number. That's why we learn the negative number. And then we are here at the decimals. So when we're talking about fractions, we can also talk about decimals, because decimals is just coming from fractions, right? So the moment you have fraction, you divide it, you can get decimals. So example here, 0.84 divided by 0.3. Now, this might be somewhat difficult for you. It looks difficult because it's 0 point something divided by 0 point something, but you can make it easier by moving the point here, the dot here, to the right side once. But the way you do it, you have to move both, so they move together. So it will become 8.4 divided by 3. So the reason you do this, so that it will be divided by a whole number instead of decimal numbers like this. So yeah, you can do the division right away. And then, yeah, imagine if 84 divided by 3 is 28, then 8.4 divided by 3 will be 2.8. You just put the dot there once you are done with the division. And as for the multiplication, yeah, you can, the trick here is you just times the whole number. So you have 0.24 times 0.02 here, you just times the 24 with 2. And you get 48. The moment you get 48, you put back the dot. Now, the way you put back the dot here, you count first the dot here that is already on the question. Okay, let's count together. 1, 2, 3, 4. So there are 4 decimal places altogether, right? So the result will follow that. The result will also end up in 4 decimal places. Okay, so what you see on the screen there is kind of shifted a bit. It should be, the underline, it should be for the 0048. So we construct the 48, yeah, we reconstruct that in a way that there will be 4 decimal places, just something like that. And then later we can head right away into the practice. So that's all for today's discussion.